and welcome to this video on using the state machine workflow layout. In this demo, we'll build a process that starts by asking the user to input an initial account balance and then lets them make payments until the initial balance is depleted or they decide to end the process. To achieve this, we'll build a state machine with 5 states: get initial balance, get payment value, make payment if the funds are available, deny payment if the funds are insufficient, and a final state to end the process. Let's begin. We start the project as a sequence and then add a state machine from the Activities panel. To get the initial balance from the user, let's add our first state. By linking it to start, it becomes the initial state of the process. We'll rename it Get Initial Balance and add an annotation to document what this state is meant to do. Get initial balance of the account. To configure the state, we need to open it, so let's double-click it. We notice that a simple state has 3 editable sections. The entry section holds the activities that will be performed when the state is entered. The exit section holds the activities that will be performed when exiting the state. And the transitions section describes the transitions this state has in relation to other states. So, what we want to achieve in the initial state of our process is to ask the user for the initial balance. For that, we'll use an input dialog activity in the entry area and prompt the user to insert a number. We'll then need to store the output of the activity in a string variable called input value. We'll make sure to set a global scope, in this case state machine, for all of the variables we plan to use in other states. Now we need to make sure that the input provided by the user is valid. In our case, the input should be a double, a number holding maximum 16 digits. To perform this check, we'll use an if activity and the double.tryPass method, which returns a Boolean value true if the conversion was successful and a false if the conversion failed. Then we'll create a new variable called current balance and its type to double and set its scope to state machine. Note that we cannot pass the result of the conversion to a variable by using the double.tryPass method in an assign activity. If the value of the input variable can be passed with the before-mentioned method, we assign its value to the current balance variable using the double.pass method. If the input value cannot be passed, we'll notify the user that the input is not valid by using a message box activity in the else block. Let's also create a new Boolean variable for storing data about the validity of the user input. We'll call it isValidInput. Set its scope to state machine and the default value to true. We'll then use an assign activity under the message box to assign the value false to isValidInput. From this point, the execution can take 2 different directions. If the input is not valid, the user should be prompted to close the payment process. This means that the process will transition to its final state and therefore the execution of the process will stop. We'll create the final state later. If the input is valid, the user will be prompted to input the value of their payment. This means that the process will transition to the get payment value state. So, let's go back to the state machine view and create this next state. The easiest way is to copy and paste the get initial balance state and then rename it to get payment value. We'll also add an annotation to document the purpose of this step. Get payment value for current iteration. Now, let's double-click to open the state and rename the input dialog to payment value. At this point, the user will input the amount they want to pay, so we need to store that input in a new variable called payment value. We'll set its type to double and give it a global scope. In the copied assign activity, we now need to replace the current balance variable with the newly created one, payment value. So, what we've just done helps us cover both the scenarios in which the user adds a valid double value or an invalid one. Going back to the state machine view, we notice that our process doesn't yet have a final state. When using a state machine, it is mandatory to have one. Let's drag a final state activity to the bottom of the workflow. We'll double-click to open the state. You can see that the structure of a final state is different from the one of a simple state. The only block available is the entry block, which holds the activities that are performed when the state is entered. As the name implies, this is the last state that the process can be in, and therefore, we cannot define any transition from a final state to any other state. Now let's go back to our example. When the users get to this point, we want to notify them that the process is finished. We'll do this by using a message box activity in the entry block of our final state. So we now have an initial state, a simple state, and a final state. It's time to add our first transitions. Up to this point, the user will input their initial balance, and next, they'll be prompted to input their payment value. That can only be triggered if we create a transition between the getInitialBalance state and the getPaymentValue state. We do that by simply connecting the two in the Designer panel. Then we double-click to open the transition and rename it Valid Input. The condition for the process to move from the initial state, getInitialBalance, to PaymentValue state is to have valid input from the user. So we set the condition that the transition should only be triggered if the isValidInput variable holds the value as true. For the scenario in which the input from the user is not valid during the initial state, getInitialBalance will create a transition from the getInitialBalance state to the final state, and will set the condition that the transition should be triggered if the input is not valid. We have now added all of the transitions starting from the initial state, getInitialBalance. After exiting this state, the user will either be prompted to add their payment amount, or if their input is not valid, they'll be prompted to finish the process. But if the user transitions to the state of adding their payment amount, there are 3 possible transitions to the next states. If they add an invalid payment input, the process will stop, and we transition to the final state. Let's add this transition. If they add a valid payment input and they have enough balance to pay the amount, their payment will be made. For that, we'll need to create a new state and 3 new transitions. If they add a valid payment input, but they don't have enough balance to pay the amount, their payment will be denied. For that, we'll also create a new state and 3 new transitions. In the case of payment denial, we want to let the user know that the transaction could not be performed due to insufficient funds. We also want to display their current balance and ask them if they want to continue with another transaction. So, how do we do that? We start by adding a new state, renaming it Deny Payment, and adding an annotation stating what the purpose of the state is. Display message about payment denial. We then open the state and add a message box activity in the entry field to notify the user that the payment could not be processed due to insufficient funds. We continue typing an expression in the message box that returns the current balance to the user. We finish by asking the user if they want to continue. We then close the expression editor and set the button's property to yes, no to get input from the user regarding what they want to do next. We'll store this input in a new string variable called continue answer. Let's make sure to change the scope of the new variable to state machine. If the user has enough balance to pay the amount, we want a state in which we'll subtract the payment value from the current balance. Then we'll let the user know that the transaction was processed, display the value of the current balance, and ask them if they want to continue. The easiest way is to duplicate the deny payment state, rename it Make Payment, and add an annotation stating that the purpose of the state is to display a message about the payment and new balance. We then use a message box in the entry block to notify the user that the payment was processed successfully. We now need to subtract the payment value from the current balance. For that, we add an assign activity above the message box and rename it reassign current balance. We then type the method for subtracting the payment value from the current balance. Now we have states in place to cover all possible scenarios. We just need to add the remaining transitions. So, if the user's payment input was valid, but they don't have enough balance to pay the amount, their payment will be denied. Thus, the process will transition from the get payment value state to the deny payment state. Let's add this transition. Open it, then name it insufficient funds, and make sure that we set the right condition. Is valid input and current balance is lesser than payment value. If the user's payment input was valid and they have enough balance to pay the amount, their payment will be made. Thus, the process will transition from the get payment value state to the make payment state. Let's add this transition. Open it, then name it sufficient funds, and make sure that we set the right condition. Is valid input and current balance is greater than or equal to payment value. Now let's make sure that we've set all of the transitions correctly from the get payment value state. Great, everything seems in place. Note that it's recommended to define transitions in a way that only one transition at a time is true, as we did in our example. We set that by adding a condition in the deny payment and make payment states to only trigger the transitions if we have a valid input from the user. However, you should know that if there are more transitions active at the same time, only the first one defined will be executed. So, let's go back to our process. Now, we only need to make sure we have all of the transitions in place for the deny payment and make payment states. There are two possible transitions from each. When prompted to continue, the user can respond with yes or no. Let's start with a scenario in which the user doesn't want to continue and selects no. We'll start with the deny payment state. In this case, the workflow transitions from the deny payment state to the final state. Let's create the transition, rename it stop, and set the condition continue answer dot equals no. We'll repeat the process for the make payment state, providing the same destination, name, and condition. Now let's cover the scenario in which the user wants to continue and selects yes. We'll start with deny payment. If the user selects yes, then they'll be sent back to adding a payment value. So, in our workflow, a transition is triggered from the deny payment state to the get payment value state. Let's create the transition, rename it continue, and set the condition to continue answer dot equals yes. We'll continue with make payment. If the user selects yes, the same happens. They'll be sent back to adding a payment value. So, in our workflow, a transition is triggered from the make payment state to the get payment value state. Let's create the transition, rename it to continue, and set the same condition as in the previous case. And with that, all of our states and transitions are now defined. We check one last time if all of the possible scenarios are covered. Yes, everything seems in place. We can now run our process. As you can see, we're prompted to add our current balance. The input provided is valid. How do we know that? Because otherwise we'd not be able to add the value of the payment. Then the payment amount is subtracted from the original balance and the new balance is displayed. We now have the option to continue the process. Once we select yes, we are asked to make a new payment. We add the value of the new payment. Then the new balance is again displayed. Once we select no, the message box notifies us that the process is finished. And that was the final state of our process. That concludes our demo on state machines. For the key takeaways, we can add the state machine layout, states and final states from the Activities panel. When using a state machine, it is mandatory to have a final state. The state activity contains 3 sections: entry, exit, and transitions, while the final state only contains 1 section, entry. The entry and exit sections enable us to add entry and exit triggers for the selected state, while the transitions section displays all of the transitions linked to the selected state. We can add transitions by connecting the states in the Designer panel and providing names and conditions for them. Thanks for watching.